Right, so in this demonstration here, we're going to be doing elephant toothpaste. So what it involves here is using a chemical called hydrogen peroxide, H2O2. This chemical here, because it is comprised of hydrogens and oxygens here, it does look a whole lot like water. I'm just going to fill up this grad cylinder here. This hydrogen peroxide here is 30%, so it is fairly concentrated. I'm just going to seal this off here when I'm not using it here. For this demo here, the reaction itself is actually already occurring. The hydrogen peroxide, we get an arrow, see if you can predict what the products are, but as you can tell, not super interesting, right? It's going too slowly to actually be appreciable. What we're going to do, just for dramatic effect here, is we're going to take some soap. Soap is going to add a few bubbles for us here. That way when the gas gets produced, it can actually get trapped by these soap bubbles. I'm going to add these ones here first, just to show you it's not the soap that causes the reaction to be faster. I even add maybe a drop or two of food coloring. These ones here, right? So now I have a bluish liquid here of hydrogen peroxide, right? Still too slow. The third chemical I'm going to add here is a chemical called potassium iodide. In grade 12, we're going to learn the actual mechanism of this here. Potassium iodide allows the reaction to occur via an easier pathway. So the second that I drop this in here, I'm going to hold it up as long as I can here. You'll see in a second why I need to drop it here, but we're going to have potassium iodide here catalyzing the decomposition of hydrogen peroxide. So let's have a look. 3, 2, 1. Let's roll around a little bit here. And there we go. You see a whole lot of steam coming off of there, so it's actually fairly hot. It's very exothermic. And basically what's happening here is the gas is being trapped under the soap bubbles, and that's why it's caused to foam upwards like this. If you YouTube elephant toothpaste here, you'll see different versions of this here. They play around with the different concentrations of hydrogen peroxide, different catalysts, different amounts of catalysts as well. Okay. But there you go, that's the catalyzed decomposition of hydrogen peroxide.